Hey everyone, I am Miss Hu, your physics teacher. In this video, we're going to go through the concept of pressure where we will learn about the definition and formula for pressure, solving questions involving pressure, as well as the applications of pressure in real life. Now, before we get into the definition and formula for pressure, first of all, we need to have a clearer understanding of what pressure is. So let's look at this hypothetical situation. Imagine that this is your hand and you are holding a push pin between your thumb and your forefinger, just like this. Now, if you were to press on the push pin with your thumb and forefinger, what do you think is going to happen? Well, yes, the push pin is going to penetrate your thumb on this very sharp point, and it's going to be very painful. So please do not do this in real life. This is just a hypothetical situation. So why is this used as an example to understand pressure? Now, this is because when you press on something, you are applying an equal amount of force on both sides. So if you had a push pin and you were pressing on the push pin between your forefinger and your thumb, you're applying equal amounts of forces. Yet, in spite of the equal amount of forces, there are very different things happening on either side. So the pin only penetrates the point where it's really sharp on the thumb, but the flat top doesn't penetrate your finger. So why the sharp point penetrates the thumb is not because of force. So a lot of people think that the penetration of the sharp point is because there is a lot of force. In this example, we can clearly see that there's an equal amount of force on both sides. So it's not because of the force that the sharp point penetrates the thumb. The difference here is the area that is in contact between the pin and your finger or your thumb. So where your forefinger is, this flat top has a much larger area, while the point is very sharp, on the thumb has a very small area. So the area influences the reason why the pin penetrates the thumb or it doesn't penetrate the finger. So in this case, the concept is pressure. So now let's look at an example in real life. And no, we're not going to be pressing a push pin with our forefinger and thumb. In this example, you can see that there is a piece of modeling clay and I'm pressing a coin onto it. Now I'm pressing it quite hard, yet you will find that there's only a small indent made in the modeling clay. However, if I were to turn the coin onto the thin edge like this, I just need to put a little bit of force and you'll find that the indent is much deeper. So pressure is quite essentially force per unit area. The formula for pressure is force divided by area. We can write this in symbol form where P is pressure, F is force, and A is area. So you can just write P equals F over A. Now let's talk about the units for pressure. The SI unit for pressure is Pascal, typically written as PA as the short form. The full name, I'll write it over here as Pascal. Now you can also write the unit based on the formula. The SI unit for force is Newton, while the SI unit for area is meter squared. So you can also write pressure as Newton per meter squared. One thing that you should be aware of is that Pascal is equivalent to Newton per meter squared. I'm just going to write here that Pascal is equal to Newton per meter squared. That means that these units can be used interchangeably. So if you got an answer of 5 Newton per meter squared, you can write it also as 5 Pascal, or vice versa. If you got a value of 5 Pascal, you can write it as 5 Newton per meter squared. Of course, Pascal is the preferred unit because that's the SI unit. Are there other units for pressure? Yes. Pressure is one of those physical quantities which has a long list of units. Now, we're not going to go through all of them here. I'll just go through some of the common ones that you will come across when it comes to answering questions in your examination. So besides writing in Pascal or Newton per meter squared, you can also write it as Newton over centimeter squared. Because as you can see from the formula, the unit for force is Newton, but area can also be expressed in non-SI units. For example, centimeter squared. So yes, you can write the answer that you calculated for pressure in Newton per cm squared. Do bear in mind though that if you had obtained the answer as Newton per centimeter squared, you cannot interchange it with Pascal because Pascal is not equal to Newton per centimeter squared. If you want to write it in Pascal, then you have to convert the centimeter squared into meter squared first, get that answer Newton per meter squared, and then you can write the answer in Pascal. If you want to just leave it as Newton per centimeter squared, well, that's fine too. So these are the more common units that are usually used to express the values for pressure. Now, let's take a look at some simple questions to understand pressure a little bit better. So you could get a very simple question like this. On which surface would a block exert A, the greatest pressure, and B, the lowest pressure? So we have here on the left side a diagram of a cuboid with the points labeled A, B, C, D, E, F, G. That's the surfaces visible to us. Then we also have measurements of the dimensions within this diagram. So to get the answer, it's quite simple. You need to understand what pressure is. As we saw in the previous slide, we know that the formula for pressure is force over area, or P equals F over A using the symbols. So in this question, what would be the force? The force would be the weight of the block. Because, as you should know by now, weight is a type of force. So there's no additional force being exerted. It's not that someone's pressing on the block. The block itself has weight, and the weight is a force exerted on the surface it is resting on. Now, the block is able to exert different amounts of pressure depending on which surface it's lying on. So, for example, if we have a block like this, the block could be resting on this surface, this way, or this way. Whichever surface it rests on, it would exert the same weight because the weight of the block is the same regardless of how you position it. So, based on this formula, if the weight is the same, the area would influence the value of the pressure. So, based on this formula, you can see that if the weight is the same, to exert the greatest pressure, the area needs to be the smallest. Looking at the dimensions written here on the diagram, you should be able to see that the smallest area is surface CDFG. On the other end of the spectrum, to get the lowest pressure, the block needs to rest on the surface with the greatest area. And the surface with the greatest area that's visible to us is ADFE. So that's how we determine the answer for this question. Now let's look at how to use this equation with numbers. So this is the same block with the same surfaces, but now we're given the value of the mass, which is 2 kilograms. Now we need to calculate the greatest pressure as well as the lowest pressure the block will exert on a surface. So first of all, we need to determine the weight of the block. We're given the mass of the block. To get the weight, we need to use the formula weight equals mass times gravitational acceleration, or W equals mg. Now, depending on whether you're taking IGCSE or SPM Physics, the value of G will differ slightly. So because of that, I'm going to solve this question 2 times. First for IGCSE and then for SPM. So let's start first for IGCSE students. If you're taking IGCSE Physics, the value of G given to you is 9.8 Newton per kilogram. So using this value, just substitute it into the equation. W equals to 2 times 9.8. This gives us 19.6 Newton. Let me fix that right thing. There we go. So to solve the question, we know that the greatest pressure is on the area which is the smallest. So we'll write here P equals F over A, where F is the weight of the block, which we've already calculated as 19.6. The smallest area visible to us is CDFG. So to calculate the area of the surface, we just need to take the product of both these dimensions. So that's 4 times 8 centimeters. So calculating this, we would get 0.6125 Newton per cm squared. So because the area here is in cm, we don't write it in Pascal, we write it over cm squared. And the final answer for IGCSE should always be written to 2 significant figures. So this would be 0.61 Newton per centimeter squared. So that's how we calculate the greatest pressure the block will exert on a surface. To solve for the lowest pressure, it's exactly the same, but this time we take the larger area. So I'm going to sub the values straight away. 19.6 divided by, we know that the lowest pressure has to be on the greatest area. So the surface with the greatest area has dimensions of 12 cm by 8 cm. So we would get a value of 0.2042, which we can then round it to 0.20 Newton per centimeter squared. So that's how we solve the question for IGCSE. I'm just going to write in a corner here that this is for IGCSE because we use a value of G as 9.8. Now, if you are taking SPM, it's actually exactly the same. The only difference is that the value for G is 9.81 meters per second squared instead of 9.8. We're still going to use the same formula of W equals to mg. So let's calculate the weight first. So the weight is 2 times 9.81, which gives us 19.62 Newton. So to solve the values of the greatest and lowest pressure, we're going to use the same formula with the same dimensions for the respective questions. So for the greatest pressure, we will need to take the area that is the smallest. So the formula is P equals to F over A, where the weight is the force. So that's 19.62. Now, depending on what the question wants, you can leave the area in centimeters squared. That means for the area in A, you will take 4 times 8. But if the question wants you to write in Pascal, you have to write the dimensions in meters instead. That's why I'm going to convert the values first into meters. So we'll have 0.04 times 0.08. So this would give us 6131.25 Pascal. And we can write it in Pascal in this case because we have written the area in meters squared. So to calculate the lowest pressure, we're going to do the same thing, but we're going to take the largest area in this diagram. So I'll substitute the value straight away now. So pressure equals to 19.62 as our force. We're going to divide this by 0.12 times 0.08. So this would give us 2043.75 Pascal. So my writing's a bit off because there's a bit of network connectivity issues, which is interfering with the way I'm writing. But anyway, the important thing is you know how to solve the question now. So let's look at some real life examples where the applications are actually useful instead of hurting people. For example, using a sharp knife to be able to cut something. For example, if you're preparing food for cooking, you need to be able to cut it into smaller pieces, like this, if you're cutting, say, a carrot into smaller pieces. It's a lot easier if you could use a sharp knife instead of a blunt knife. Why is it that a sharp knife is able to cut more easily than a blunt knife? It's because a sharp knife has very thin edges, which means that the area is very small. So you could apply just a little bit of force. The pressure is very high, making it easy for you to cut through the object. If you have a blunt knife, that means that the edge is thick. So the area is bigger. You need a lot more force to be able to cut the object. Now, here is another useful application of pressure. Hammering a nail into a piece of wood. Now, why is this an application of pressure? Because as you can see, the area of the nail that is in contact with the wood is a sharp point, which means that it has a very small area. So with just a little bit of force, we can generate high pressure, enabling the nail to penetrate the wood easily. Now, these are the positive applications of high pressure. There are also positive applications of low pressure. So in order to create lower pressure, we need to distribute the force over a greater area. In what situations would we want lower pressure? So in this example, on the left-hand side, you'll find that there are a lot of connections involving screws and nuts, especially to hold different parts together, for example, in a shelf or a table. The nut is used to hold the screw in place, but the force can be quite high because a lot of force is needed to hold the joints together. So in order to reduce the pressure exerted, we normally use a washer, which is a large piece of circle like this, which distributes the force over a greater area. Without the washer, the force can be quite great on the joint, causing the hole where the screw is in to get larger and the whole thing could fall apart. So if you're wondering, is this normally used? Take a look at some of the furniture in your house. You'll find that many joints usually have a washer in order to spread the pressure. Another example of creating lower pressure would be in this case, for example, a tractor. Now, we know a tractor has great weight, which means that it has a potential to create greater pressure. In order to reduce the pressure, we need to create a larger area of the wheels. So that's why you find that heavy vehicles like tractors tend to have large wheels. So yes, of course, the larger wheels is to be able to support the weight of the heavy tractor, but you'll find also that the wider the wheels, the greater the area. And as you can see in this diagram here, they have many wheels here, a total of 8 wheels in order to create a larger area, therefore creating a lower pressure. So with lower pressure, it is less likely that a tractor would sink into the soft ground. Now there's more to learn about pressure. In terms of liquid and gas pressure, the formula that you've learned of P equals F over A generally can be applied, but there are significant differences. Because there's so much to talk about, we will discuss liquid and gas pressure in separate videos. And that is it for this video. So if you found this video to be educational and helpful, do click like and leave a comment to let me know how you have found this video to have helped you. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. For access to notes, quizzes, and syllabus updates, do check out my website at physicsrocks.com. Check out my videos on my YouTube channel on other topics which you might find helpful. Subscribe to my YouTube channel for more free physics lessons from your physics teacher, Miss Hu. Happy studying!